Good evening, students. Good evening, students. Here, mainly in this introduction to trigonometry, the here in this video class, we'll discuss about trigonometric identities and their applications. One more video I will do on trigonometry ratios as well as their applications. Let us go with next slide. Mainly, we know what is use of trigonometry meant to find height of the buildings, height of the towers, height of the trees, distance between 2 points of river, as well as distance between any 2 points, length of the canal. Like these applications we'll use. Mainly trigonometry is useful in the field of engineering as well as physical sciences. And the word trigonometry derived from the Greek word tri plus gon plus metron, which is method of three sides or three angles of a right triangle. If you know, it is firstly it is recorded in Egypt and Babylonian. So astronomers also used, and in different fields we can use trigonometric concepts of trigonometry. Now let us go with the next slide with trigonometric ratios. To apply or to use the concept of trigonometry, first we should learn six trigonometric ratios. What are they? Sine, cos, tan, cosecant, secant, cot. Sine is defined as in any right triangle, longest side itself is called hypotenuse. So here hypotenuse is in triangle ABC, if angle B is 90 degrees, in any triangle opposite to 90 degrees is called longest side hypotenuse, and the side opposite to given defined angle is adjacent. Opposite, you know, adjacent house, opposite house, like that, adjacent side, opposite side. In this given triangle, sine angle A, sine of A, simply we can write sine A also, short form. Side opposite to angle A by hypotenuse. If you observe for angle A opposite side BC, hypotenuse is fixed in any right triangle opposite to 90 degrees, that is AC. In this triangle AC, and cos is defined as the ratio between side adjacent to given angle by hypotenuse. Here given angle is angle A, that is why AB by AC. Tan is defined as side opposite to angle A by side opposite to angle A, and simply tan is defined as another way, sine by cos, sine of that angle by sine of that angle by cos of same angle, also defined as tan. So sine theta, if I take theta as angle theta, which is Greek letter, so it is defined as tan theta. Reciprocal of tan is cot, reciprocal of sine is cosecant, reciprocal of cos is secant. So let us discuss all the trigonometric ratios and their identities. So now let us go with next slide. So in next slide it is given cosecant, which is reciprocal of sine, hypotenuse by side opposite to given angle AC by BC. Secant is reciprocal to cosine, or cosine is nothing but cos, children. You remind as short form as cos only. 1 by cos, which is defined as hypotenuse by side opposite to angle A, BC by AC by BC. Cot is cot, a short form of cotangent is cot, and cot is reciprocal to tan, which is 1 by tan, side adjacent to angle A, side opposite to angle A, AB by BC. If you define for this ratio, for this triangle, if you take angle C, adjacent side of angle A become opposite side to angle C. So opposite side of angle A become adjacent side to angle C. Hypotenuse never changes. The ratio defined above abbreviated as sin A, cos A, tan A, cosecant A, secant A, and cot A respectively. So six trigonometry ratios are there. Cosecant, secant, and cot are respectively reciprocals of sin, cos, tan are cosecant, sin reciprocal cosecant, cos reciprocal secant, tan reciprocal cot. Let us go with next slide, students. In this slide, we will find the values. Sine ratio, already I gave one shortcut technique. Use this shortcut technique, you can understand easily. We will remember root 0 by 4, root 0 by 4, root 1 by 4, root 2 by 4, root 3 by 4, root 4 by 4. If you remember this technique, you can remember, you can write sine ratio. After writing sine ratio value at 0, 30, at 0, 30, 45, 60, automatically it is reciprocal of, reverse order. Sine and cos are complementary to each other. So if we write reverse order of uh, sine, we get cos, sine by cos tan, then after we simplify. See, 0 by 4, 0. So sine 0 value is 0. Root 1 by 4 value 1 by 2. Sine 30 is 1 by 2. Actually plus or minus 1 by 2. Never negative. We will do only acute angles in 10th standard. If we do cancellation, 2 1s, 2 2s, root 1 by 2 is 1 by root 2. So sine 45 is 1 by root 2. Root 3 by 4 simplified form root 3 by 2. So sine 60 root 3 by 2. 4 4 cancel. Simplified form is root 1. 1 is 1. Sine 91. If we write reversely, sine and cos are complementary to each other. So if we write reversely, cos 0 value 1, cos 30 value root 3 by 2, cos 45 1 by root 2, cos 60 1 by 2, cos 90 0. Sine by cos if you do, you get tan. That is why 0 by 1 0, 1 by 2 root 3 by 2, 2 2 cancel, 1 by root 3, 1 by 2 1 by 2 cancel, 1, root 3 by 2, 2 2 cancel, root 3, something by 0 undefined or not defined. That is why tan 0 value 0, tan 30 value 1 by root 3, tan 45 value 1, tan 60 root 3, tan 90 undefined, not defined. Cosecant is reciprocal to sine, 1 by 0 not defined. All reciprocals will take. Secant is reciprocal to cos, cot is reciprocal to tan. In this way, we can remember this table, students. Let us go with next slide. In the next slide, it is given how sine is defined, cosine and reciprocal, and remaining trigonometry ratios easily determined, and the values of this one we know, and never exceeds cosine and cos never exceeds 1, whereas secant, cosecant always greater than or equal to 1. Now let us go with next slide, students. So let us go with next slide. In the next slide, it is given complementary angles. It is deleted actually, but also simply we will decide, we will explain sine 90 minus a cos a. That is why sine and cos are complementary to each other. Cos 90 a sin a, tan 90 minus a cot 90 minus a tan a, secant 90 minus a, cosecant 90 minus a, secant a. And sine square a plus cos square a is equal to 1. First identity, secant square a minus tan square a is 1. It is, these two are conditional identities. This is universal identity. It is conditional identity. In this identity only these are true. Cosecant square a we can write 1 plus cos square a. So by using these three identities we will do problems in this video class, and we'll do some applications. Let us go with next. These are the proofs of identity, students. First identity proof we can apply by taking sine square a opposite side, adjacent side, hypotenuse. If we substitute in the sine square a plus cos square a, 1 it is proved by using Pythagoras theorem. Again 1 plus tan square a is equal to secant square a is also proved by using Pythagoras theorem. So now again third identity, which is cot square a is equal to cot square a plus cot square a plus 1 equal to cosecant square a. These three identities, trigonometric identities are proved by using Pythagoras theorem. Now let us discuss the problems. First one, it is given, prove that cos square a plus 1 by 1 plus cos square a is equal to 1. Now let us, while proving trigonometric identities or trigonometric applications of trigonometric identities, we can take LHS, we can prove equal to RHS. Sometimes we'll take RHS, we can prove LHS, or else we'll prove LHS separately, RHS separately. Any method is applicable. Any method is approachable. So cosecant cos square a plus 1 by 1 plus cos square a. From first identity, instead of from third identity, instead of 1 plus cos square a, we can write cosecant square a. So instead of 1 plus cos square a, we wrote cosecant square a. When we wrote 1 by cosecant is sine. So cos square a plus 1 by cosecant square a. As 1 by cosecant theta is sine theta, instead of 1 by cosecant square a, we can write sine square a. So cos square a plus sine square a, how much from first identity? 1. Here we used third identity, here we used first identity. So we took LHS and we proved RHS. Next problem is given, prove that root over 1 minus cos theta by 1 plus cos theta equals to cosecant theta minus cot theta. To prove this one, let us take RH, LHS and rationalize denominator. What is rationalizing factor? In class 9 you learn. If it is denominator is in form of a plus b, we'll multiply by a minus b, both numerator and denominator. And then after, if denominator is a plus b form, we'll multiply by a minus b. So here 1 plus cos theta is given. So multiply both numerator and denominator by 1 minus cos theta to rationalize denominator. Then we have root over 1 minus cos theta into 1 minus theta, 1 minus cos theta whole square by 1 minus cos square theta. But we applied formula. But from first identity, we can write 1 minus cos square theta. We have first identity, sin square theta plus cos square theta equals to 1. From that, we can write 1 minus cos square theta as sin square theta. It is first identity. By using first identity, we wrote 1 minus cos square theta as sin square theta. So instead of that, we wrote root over 1 minus cos square theta by sin square theta, because instead of 1 minus cos square theta, we wrote sin square theta from first identity, since it is. So after that, here remove square root, means the square belongs to as well as 1 minus cos square theta whole square, 1 minus sin square theta, square root cancel, 1 minus cos theta by sin theta. Now expand it, 1 by sin theta minus cos theta by sin theta. What is 1 minus sin theta? Cosecant theta. Cos theta by sin theta, cot theta. So we took LHS, we rationalized denominator, and we used first identity, and we simplified. Finally we got RHS. So LHS equals to RHS. So by using identities, we can do like this. Let us go with the next application. Here it is given that sin square a plus 1 by 1 plus tan square a equals to 1. We have to prove. Simple, students. Just now we did before. Same way here. Sin square LHS you take. Sin square a plus 1 by 1 plus tan square a. We know 1 plus tan square theta is secant square theta from second identity. Previously we used first identity, third identity. Now second identity. And 1 by secant theta cos theta. By using this result, we will simplify. Instead of 1 plus tan square a, from second identity we can write secant square a. But 1 by secant theta is cos theta. So instead of 1 by secant square a, we can write cos square a. Already here sin square a is there plus cos square a. From first identity, sin square theta plus cos square theta equals to 1. So we can write instead of sin square a plus cos square a 1. We took LHS, we proved RHS. Let us go with next problem. In next problem is given that prove that 1 plus cos square theta into tan theta by secant square theta equals to cot theta. To prove this one, let us take 1 plus cos square theta into tan theta by secant square theta, LHS. Same approaching method. 1 plus cos square theta into tan theta by secant square theta. As we know from third identity, instead of 1 plus cos square theta, what can we write? Cosecant square theta. Instead of secant theta, what can we write? 1 by cos theta. Instead of cosecant theta, what can we write? 1 by sin theta. Because these three results will apply here. So first step, 1 plus cos square theta we wrote as cosecant square theta into tan theta by secant square theta. But cosecant square theta is nothing but 1 by sin square theta. Secant square theta is nothing but 1 by cos square theta. That is why we took reciprocal. So here 1 by sin square theta, it will become denominator. Here we wrote 1 by cos square theta, it will take reciprocal. Now 1 cos theta and 1 cos theta cancel. 1 sin theta and 1 sin theta cancel. We have finally cos theta by sin theta, which is cot theta. Cos by sin is secant theta. Cos by sin is cot theta. And students, here we wrote 1 by sin square theta. Sin square theta will become denominator. 1 by cos square theta, reciprocal. Cos square theta will become numerator. 1 cos theta, 1 cos theta. 1 sin theta, 1 theta cancel. We have cos theta by sin theta, which is cot theta. So we took LHS, we proved RHS from this result. So we use the third identity and secant theta as 1 by cos theta, cosecant theta 1 by sin theta. Let us go with the next slide, students. So in this slide it is given that prove that tan square theta minus sin square theta equals to tan square theta into sin square theta. Let us take LHS same way. But we know that tan theta we can write sin theta by cos theta. So tan square theta what can we write? Tan square theta we can write from this formula. Tan square theta we can write sin square theta by cos square theta minus sin square theta by 1 for our convenience. What is LCM over here? Cos square theta. So cos square theta cancel, sin square theta minus, if you do cross multiplication, sin square theta into cos square theta. But if you observe here, sin square theta is common. We can factorize sin square theta. If you factorize no number means we can write 1 into sin square theta. When we factorize sin square theta, we have 1 minus cos square theta by cos square theta. But sin square theta into, we know 1 minus cos square theta is sin square theta from first identity. As we know from first identity, sin square theta plus cos square theta equal to 1. So we can write 1 minus cos square theta from first identity sin square theta. So sin square theta into sin square theta by cos square theta. What is sin square theta by cos theta? We know sin theta by cos theta tan theta. Square is there means tan square theta. So we have sin square theta into tan square theta. In multiplication, if we change the order, no change in value. So tan square theta into sin square theta RHS. So we took LHS, we proved RHS. Here we use tan theta is equal to sin theta by cos theta and first identity. This result, by using this result, we simplified wherever required we factorize to get LHS to RHS. Now next problem is given. Prove that cos theta minus tan theta equals to 2 cos square theta minus 1 by sin theta cos theta. Same approaching method. Let us take LHS. Cos theta minus tan theta. How cot is defined? Cot is defined as cos by sin. Tan is defined as sin by cos. And here we use one more identity. Sin square theta equals to 1 minus cos square theta. So after writing this, LCM, what is LCM over here? Substitute. Here substitute cot theta as the 1 cos theta by sin theta. Tan theta as sin theta by cos theta. Take LCM. Sin LCM, do cross multiplication. Cos theta into cos theta, cos square theta minus sin theta into sin theta, sin square theta. Cos square theta minus, change everything in terms of cos to get the result. So we can write 1 cos square theta minus, instead of sin square theta, we can write 1 minus cos square theta from first identity. Minus of 1 minus cos square theta by sin theta cos theta. Then cos square theta minus plus minus into plus minus 1 minus into minus plus cos square theta. Then we have cos square theta plus cos square theta. 2 cos square theta minus 1 by sin theta cos theta. What we need here RHS? We took LHS, we proved RHS, hence proved. Let us go with next slide, students. So in the next slide, what is given? We have to prove that cos square theta by sin theta minus cosecant theta plus sin theta is 0. This result equal to 0, we have to prove. How to prove? Let us take LHS. After taking LHS, we have cos square theta by sin theta minus cosecant theta plus sin theta. Write all terms in terms of sin and cos. So cos square theta by sin theta minus cosecant theta, we can write 1 by sin theta plus sin theta. Take LCM here. There is no number means 1. LCM is sin theta. Cos square theta minus 1 plus sin theta into sin theta, sin square theta. We know cos sin square, write sin square theta, cos square theta together. Minus 1 by sin theta. We know sin square theta plus cos square theta is 1. 1 minus 1 how much? 0. 0 by something? 0. 0 by something? 0. So finally we have here, by using first identity, we wrote sin square theta plus cos square theta is 1. 1 minus 1, 0. 0 by something? 0. RHS. We took LHS, we proved RHS. Hence proved. Now next problem. 1 plus sin A plus 1 by 1 by 1 plus sin A plus 1 by 1 minus sin A is 2 secant square A. To prove this one, take LCM. 1 plus sin A into 1 minus sin A is 1 minus 1 A square minus B square formula. 1 square is 1. 1 square is 1 sin square A. And here if you take LCM, do cross multiplication. 1 minus sin A plus 1 plus sin A cancel. So 2 by 1 minus sin square A. But from first identity we know sin square theta plus cos square theta is equal to 1. From that 1 minus sin square theta we can write cos square theta. So 2 by cos square theta. 2 by cos square theta we can write 2 by cos square A. We can write 2 into 1 by cos square A. So what is 1 by cos square A? Secant square A. From that we proved 2 secant square A. We took LHS, we proved RHS. So this manner we will prove the result by using identity. So please do like this, students. 1 by cos square is 2 secant square A. 2 into 1 by cos square A, 2 secant square A, RHS proved. We took LHS, we proved RHS by using the identities. Let us go with next slide. In the next slide it is given, we have to prove that 1 plus sin theta whole square plus 1 minus sin theta whole square by 2 cos square theta equals to 1 plus sin square theta by 1 minus sin square theta. Again take LHS. It is in form of a plus b whole square, a minus b whole square. So what is a plus b whole square? Expand from a square plus b square plus 2ab. And a minus b whole square, a square plus b square minus 2ab. So 1 square is 1 plus sin square theta plus 2 into 1, 2 sin theta plus 1 sin square theta minus 2 sin theta. And here we can write here plus 2 sin theta minus 2 sin theta cancel. So we have 1 plus 1, 2 sin square theta plus sin square theta, 2 sin square theta by 2 cos square theta. 2 is factorized. 2 of 1 plus sin square theta by, instead of cos square theta from first identity, we can write 1 minus sin square theta. So 2 cancel. Then after we wrote 1 plus sin square theta by 1 minus sin square theta. Keep in mind students, here we can write cos square theta from identity. Cos square theta, we can write it as cos square theta equals to 1 minus sin square theta from first identity. To prove RHS, we used this result. Then after root over 1 plus sin A 1 by 1 minus sin A is secant A plus tan A, we have to prove. Just now we did this model problem, rationalized denominator. If you what is rationalizing factor of 1 minus sin A, 1 plus sin A, multiply numerator also same thing. In class 9 you learn, if it is a plus b form, a minus b is rationalizing factor. From that 1 plus sin A, 1 plus sin A into 1 plus sin A, 1 plus sin A whole square whole by 1 minus sin A into 1 plus sin A minus b into a plus b, a square minus b square. 1 square value is 1. So 1 square minus sin square A, where 1 square is 1, we can write directly 1 minus sin square A. After that we know from first identity 1 minus sin square A is cos square theta. So we wrote 1 minus sin square A as from first identity cos square A. And if you remove square root cancel. If we remove square root, it will become 1 plus sin A by cos A. If you expand it, 1 by cos A plus sin A by cos A. What is 1 by cos A? Secant A, which is reciprocal to each other. Sin A by cos A, tan A. We took RHS by rationalizing. We got one form, expanded by using secant A tan A formula. We wrote secant A plus tan A, RHS we proved. Here also students, similar model. Here it is given LHS root over 1 plus sin theta by 1 minus sin theta plus root over 1 minus sin theta by 1 plus sin theta. Just now I said if denominator is in the form of a plus b, a minus b is the identity, a minus b is the rationalizing factor. If it is a minus b, a plus b is the rationalizing factor. Here by rationalizing denominator, we got from root over 1 plus sin theta whole square by 1 minus sin square theta plus root over 1 minus sin theta whole square by 1 minus sin square theta. By applying identities, we have root over 1 plus sin square theta, 1 plus sin theta whole square by cos square theta plus root over 1 minus sin theta whole square by cos square theta. Remove square root, we have 1 plus sin theta by cos theta plus 1 minus sin theta by cos theta. Take LCM, cos theta is LCM here. So 1 plus sin theta plus 1 minus sin theta. So here plus sin theta minus sin theta get cancel. Here plus sin theta minus sin theta get cancel. So after cancel both of these values, 1 plus 1 2 by cos theta. We know secant theta cos theta is reciprocal to secant theta, which is RHS. So hence it is proved. Let us go with the next slide, students. So in this third bit it is given, prove that root 1 plus cos theta by 1 minus cos theta plus root over 1 minus cos theta by 1 plus cos theta equals to 2 cosecant theta. Same process, LHS, rationalized denominator, we are approaching by taking LHS to proving RHS. Again rationalizing denominator, same model to previous problem. We have 1 plus cos theta for rationalizing denominator first part plus 1 minus cos theta by second part. So we have root over 1 plus cos theta whole square by a minus b into a plus b, a square minus b square, which is 1 square is 1. Here also 1 square is 1. We used identity a plus b into a minus b into a plus b, a square minus b square. From that we can write 1 plus cos theta whole square root over by 1 square minus cos square theta plus root over 1 minus cos square theta 1 minus cos theta whole square by 1 minus cos square theta. If you simplify, students, we got the result. And by using the identity we have here, we have 1 plus cos theta by, here 1 minus cos square theta we can write sin square theta, 1 minus cos square theta we can write sin square theta. Remove square root cancel. 1 plus cos theta by sin theta plus 1 minus cos theta by sin theta. Here sin theta is LCM. As sin theta is same, sin theta is LCM. 1 plus cos theta plus 1 minus cos theta. Cos theta cancel. 2 by sin theta. As we said, sin theta, cosecant theta reciprocal to each other. We got RHS. We took LHS, we proved RHS. Similarly, we'll go with the next problem. Cosecant A by cosecant A minus 1 plus cosecant A by cosecant plus A equal to 2 secant square A. We have to prove. Let us take LHS. Most of the cases we will take LHS will prove to RHS. But few cases we have to take RHS to prove LHS. Some cases LHS RHS separately. Any approaching method is applicable, but we should do proper way. So here what is LCM over here? First step LHS. After take LCM. LCM is cosecant A minus 1 into cosecant A plus 1. And if you take uh, LCM, then after we got cross multiplication, cosecant A, in this step we get cosecant A into cosecant A plus 1 plus cosecant A into cosecant A minus 1. When we multiply cosecant A by with cosecant A plus 1, cosecant A into cosecant A, cosecant square A plus cosecant A into 1 cosecant plus cosecant A into cosecant square A plus into minus cosecant A. Here plus cosecant A minus cosecant A cancel. As we know, cosecant square A plus cosecant square A 2 cosecant square A by, it is in form of A minus B into A plus B. What is identity of A minus B into A plus B? A square minus B square, where A is cosecant A, B is 1. So cosecant square A minus 1 square, which is nothing but cosecant square A minus 1. So after applying A minus B into A plus B, A square minus B square, we have cosecant square A minus 1. Then after we have cot square A, 2 cosecant square A by cot square A. As we know, cosecant square A we can write sin square A by cos square A. Cot square A we can write cos square A by sin square A. If you write 2 into 1 by sin square A, this will become denominator, and cos square by sin square A will come, that will become reciprocal. So sin square A get cancelled. 2 by cos square A, how much? 2 secant square A. We took LHS, we proved RHS. Let us go with next slide. So here in this slide it is given, prove that cosecant theta minus sin theta plus 1 by, sorry children, cos theta minus sin theta plus 1 by cos theta plus sin theta minus 1 equals to cosecant theta plus cot theta. Same model in NCERT textbook, it will be we have to prove secant theta plus tan theta. Both the problems are same model, only difference, instead of cosecant theta plus cot theta, we'll prove secant theta plus tan theta. Both are same. It is there in secant NCERT textbook. Now let us, well, proving cot theta, how cot is defined? Cos by sin. So denominator must be sin. So divide both numerator and denominator by sin. But in that problem, while proving secant theta plus tan theta, we will divide by cos. But here we have to prove cosecant theta plus cot theta divide by sin. So both numerator and denominator divided by sin. So we have cos theta by sin theta minus sin theta by sin theta plus 1 by sin theta whole by again cos theta by sin theta plus sin theta by sin theta minus 1 by sin theta. As we know here, sin theta cancel. Here also sin theta cancel. Then what we have? Cot theta minus 1 plus cosecant theta by cot theta plus 1 minus cosecant theta. This result we have. Now to prove the required result, we have different methods. But here multiplied both numerator and denominator by cot theta plus cosecant theta. This is one method. In spite of that, we can do another method also. That is, any method is applicable. We by using identity cot theta plus cosecant theta, only numerator will change, denominator remains same. So instead of minus 1, we can write bracket of cosecant square theta minus cot square theta. It is third identity. By using third identity, we will do whole by denominator remains same. Cosecant theta. What is the denominator here? Cosecant theta, cot theta minus cosecant theta plus 1. Here now, here cosecant, here we can write a square minus b square form. That is cosecant square theta minus cos square theta. We can write cosecant theta plus cos theta, cosecant theta plus cot theta, and cot theta plus cosecant theta will cancel, will factorize. Numerator denominator cancel. Then we get the required value. Let us do, students. So here, according to given question, we can write it as, now next step we can write it as, what is there, cot theta cosecant, let me take cosecant theta plus cot theta, no issue. Cosecant, if you change order in addition, no change in value. Cosecant theta plus cot theta, and that is a square minus b square form, minus of a plus b into a minus b, that we can write cosecant theta plus cot theta into my plus cot theta within the bracket. Let me take square bracket here. It is minus, students, and into a plus b into a minus b, a square minus b square form, cosecant theta minus cot theta. Now if you observe, denominator remains same, denominator no change, denominator is cot theta plus cosecant theta plus 1. Here it is minus, students, here it is minus. So it is minus, here it is minus. Now if you observe, students, here cosecant theta plus cot theta we have, for our convenience let me write 1 into, is cosecant theta plus cot theta, here cosecant theta plus cot theta. In this numerator, these two is common. If you factorize, these two cancel. How we can do? Next step, students. Cosecant theta plus cot theta is, factorized. Next step. We factorize cosecant theta plus cot theta. So cosecant theta plus cot theta is factorized. Cosecant theta plus cosecant theta plus cot theta is factorized. If you factorize this one, what is left over? Already I said we wrote as 1. So 1 minus of a plus b, we factorize a plus b form, I mean cosecant theta. So cosecant theta and cosec theta plus cot theta within the bracket, square bracket, whole by denominator remains same. What is denominator remains same? Cot theta minus cosecant theta plus 1. That is remains same. If you observe, plus 1. If you observe, these two are of the same, so these two get cancelled. What is left over? Cosecant theta plus cot theta, RHS is left over. This is one of the easy method to do. Let us go with the next problem, students. So we proved cosecant theta plus cot theta, which is RHS. So LHS we took, we divide by sin theta. Here we applied identity. We did this. Both the methods are applicable, students. Any method is applicable. Let us go with the next problem. So next problem, it is given tan square a plus cot square a equal to secant square cosecant square a cosecant square a minus 2. Let us take LHS, and tan square a we can write sin square a by cos square a. Cos square a we can write cos square by sin square a. Take LCM. Sin square a into sin square a, sin power 4a plus cos square a into cos square a cos power 4a by sin square a sin cos square a. So here we can write sin power 4a as sin square a whole square cos square a whole square. So a square plus b square formula what? A plus b whole square minus 2ab. From that sin square a, from that we can write sin square a plus cos square a whole square minus 2 sin square a cos square a by sin square a cos square a. From first identity we know sin square a plus cos square a is 1. So 1 square minus 2 sin square a cos square a. 1 minus 2 sin square a cos square a. 1 minus 2 sin square a cos square a. So by sin square a cos square a expanded 1 by sin square a cos square a minus 2 sin square a cos square a by sin square a cos square a. These two same they get cancelled. So what is left over? 1 by sin square a is cosecant square a, 1 by cos square a is secant square a minus 2. So we proved secant square a cosecant square a minus 2 RHS. We took LHS, but here you need to remember sin square a plus cos square a, sin power a 4a, that we can write. For our convenience to use a square must be square form, we can write sin square a whole square plus cos square a whole square. Power 4 we can write whole square. Whole square we wrote a square plus b square form. Denominator is same, sin square a cos square a. But numerator we applied one formula which you learned in previous class. A square plus b square equals to a plus b whole square minus 2ab. Here a is sin square a, b is cos square a. Simplified we got. Next slide. We go with next slide, students. In the next slide, it is given that if x is a secant theta plus b tan theta and y is a tan theta plus b secant theta, it is reversed. It is reversed. Then after we have to prove that x square plus y square equals to, it is x square plus y square equals to x square minus y square. X square minus y square equals to a square minus b square. So to prove this result, we will write like this. X is given as a secant theta plus b tan theta. Y is given a tan theta plus b secant theta. Equation 1, equation 2. Squaring on both sides and subtracting. Do squaring and apply subtract. X square minus y square. Or else take LHS. LHS equal to x square minus y square. X is what? A secant theta plus b tan theta whole square minus a tan theta plus b secant theta whole square. Already I said we can do any approaching method. We took LHS, we substituted x value, y value, simplified. It is a plus b whole square form, a square plus b square plus 2ab. So a square secant square theta plus b square tan square theta plus 2ab secant theta tan theta minus of. Again here also a plus b whole square form, a square tan square theta plus b square secant square theta plus 2ab tan theta secant theta, and simplify. We can write a square terms one side, b square terms one side, please write. When we multiply by minus symbol, symbol will change and these two get cancelled automatically, plus and minus get cancelled. This is 2ab, students. So if you factorize a square from this, a square of secant square theta minus tan square theta plus b square, if you factorize secant square theta tan square theta minus secant square theta. But if you reverse, if you factorize minus symbol, plus can change to minus and it reversed. But we know second identity secant square theta minus tan square theta is equal to 1. So a square into 1 minus b square into 1, a square minus b square. We took LHS, we proved RHS. This is one of the approaching method. And again here it is given cosecant theta plus cot theta is equal to m, cosecant theta minus cot theta is equal to n. Prove that mn is equal to 1. Let us take multiply m into n. Let us take LHS, m into n, cosecant theta plus cot theta into cosecant theta minus cot theta. We know a minus b into a plus b, or a plus b into a minus b, a square minus b square. Cosecant theta, cosecant square, a square means cosecant square theta minus cos square theta b square. So we know third identity cosecant square theta minus cos square is equal to 1. Let us go with next slide. In this slide it is given that prove that secant a plus tan a minus 1, secant a minus tan a plus 1 is 2 tan a. Take LHS, multiply by using this identity. Let us take secant a plus tan a is a, secant a secant a as a, Let us take secant A as A, tan A tan A minus 1 as tan A minus 1 as B. So secant A of plus tan A minus 1, secant A minus of tan A minus 1. It is in form of A minus B into A plus B, which is A square minus B square. Secant A whole square minus tan A minus 1 whole square. It is expand form of A minus B whole square. Secant square A minus of A square means tan square A plus 1 square is 1. 1 square we know 1 minus 2 into 1 into 2 tan A, 2 tan A. Secant, when we multiply by minus, symbol will change. 1 square is already we know 1. So after the change, after multiplying with minus symbol, we have secant square A minus tan square A minus 1, 1 plus 2 tan A. We know secant square A minus tan square A is 1, 1 minus 1 get cancelled. 2 tan A is left over RHS. We took LHS by using identities, we proved RHS. Again here also same concept, x cos theta plus y sin theta is equal to 1, x by A, sorry, x by A cos theta plus y by B sin theta is equal to 1, x by A sin theta minus x by y by B cos theta is equal to 1. Prove that x square by A square plus y square by B square is equal to 2. So let us take this one, and by squaring and adding, by taking LHS, we have x square. So after that we have the result, apply identity, expand it, we got final answer x square by A square plus y square by B square equal to 2. So apply identity and simplify. Let us go with next slide, students. In the next slide, it is given that A cos theta plus B sin theta is equal to M. A sin theta minus B sin theta is equal to N. Prove that. Simple method students will take LHS or RHS. Sometimes we'll take LHS, sometimes we get LHS, RHS. In this case, we'll take RHS to prove easily. M square plus N square equals to, it is in form of A plus B whole square, A cos theta plus B sin theta whole square plus A sin theta minus B cos theta whole square, A square plus B square plus 2AB, that is A square cos square theta plus B square sin square theta plus 2AB sin theta cos theta plus A minus B whole square means A square minus A square plus B square minus 2AB. So same way, A square sin square theta plus B square cos square theta minus 2AB sin theta cos theta. These two are same, different signs, cancel. A square sin square theta plus A square cos square theta plus B square sin theta plus B square cos square theta. If we factorize A square over here, A square of sin square theta plus A sin square cos square theta, A square of sin square theta plus cos square theta plus B square of sin square theta plus cos square theta. From first identity we can write 1, A square into 1, A square, B square into 1, B square. So A square plus B square, we proved. Now it is the same approaching method. If cos A plus cos square A is equal to 1, prove that sin square A plus sin power 4A is 1. Let us take cos A plus cos square A is 1. Transpose another side of equality, it will become 1 minus cos square A. 1 minus cos square A is sin square A. Means, let us take equation 1. From 1, what can we write? Instead of cos A, we can write sin square A. From this, we will take LHS. Sin square A plus sin power 4A equals sin square A plus sin power 4A. We can write sin square A whole square. Instead of sin square A, we can write cos square. Cos A, sorry, from 1 we can write cos A, sin square, cos square A, sin cos A plus cos square A. How much here according to problem 1? So we proved it is also 1. That's it. Next problem. So tan theta plus sin theta is equal to M. Tan theta minus sin theta is equal to N. Prove. And M equals to N. Show that M square minus N square is 4 root M. Then let it be. Now M is tan theta plus sin theta. N is tan theta minus sin theta. We have to prove this one. Let us take M square minus N square, and we will approach LHS to RHS. Substitute M value as tan theta plus sin theta square is there, minus tan theta minus sin theta whole square. Apply, expand by using A minus B whole square, A plus B whole square. A square plus B square plus 2AB minus of, when we multiply by minus, symbol will change. Minus tan square minus sin square, because multiply by minus symbol, symbol will change. So we have here plus, here plus 2, sorry. So according to question, we have here, from identity we have here tan square theta minus tan square theta, sin square theta minus tan square theta, cancel. 2 plus 2, 4 sin tan theta sin theta, equation 1. We will, already I said, we have different approaching method, LHS to RHS, RHS to LHS, LHS RHS separately. Here we will prove LHS RHS separately. We proved LHS value, RHS we take 4 root mn, substitute 4 into tan theta root over tan theta plus sin theta into tan theta minus sin theta, 4 into root over A plus B into A minus B, A square minus B square, tan square theta minus sin square theta. But we can write tan square theta as sin square theta by cos square theta, sin square theta by 1. Take LCM as cos square theta. So 4 into root over sin square theta is factorized 1 minus cos square theta by cos square theta. 1 minus cos square theta is sin square theta. sin square theta into sin square theta by cos square theta root over 4 into root over sin square theta trans square theta remove square root 4 tan theta sin theta. We have RHS LHS equal, hence it is proved. So these are the models we have discussed. So students, please go through well, and you can get clarification doubts of your doubts by using this my mobile number, and keep on watching students. Thank you.